right. So I want to explain to you how simple the data analysis problem is. Now I've given you that Excel file that has like the different blocks in there. I forgot. I don't think I gave you. If I did give you I think I gave you a practice block and a real block for each of the two trials. We can think of it as the congruent trials, white and good, black and bad, and the incongruent trials, white and bad, black and good, right? So to put that in perspective, you got that Excel file, and it's like, well, what do? You got to use this improved algorithm on page 214 of the article. Now, you use data from 3 and 4, so that's practice and real blocks of the, let's just say incongruent IAT, and B6 and B7, which are the practice and real blocks of the congruent after you swap them around. But it's only of the trials when you're doing both tasks at the same time. So first step is eliminate trials with latencies greater than 10 milliseconds or 10 seconds. And then you eliminate subjects for whom more than 10% of the trials have latencies less than 300 milliseconds. Now, you're not going to eliminate it, right? But that's step one for whom... Yeah, sorry about that. Ugh. Okay, so, that's all you do. Eliminate subjects for more than, and that's not going to be a problem for you. Use all trials just out of these blocks, so don't worry about that. No extreme value treatment beyond step 2. And then you compute the mean of correct latencies for each block. So this means you have to go through it and you have to only include the correct responses in the calculation of the mean. So for each block, that's B3, B4, B5, B6, B7, right? So essentially what you do there is you remove all the latencies for the incorrect responses, right? Because those don't matter. They got it incorrect. So that latency no longer matters. Compute one pooled standard deviation for all trials in blocks 3 and 6. So that's practice and practice. And 4 and 7, real and real. Okay, so you just put all those together and you use Excel to calculate the standard deviation, or you do it by hand. I would honestly use the Excel that I gave you. You can do a lot of this by hand. You can eliminate the trials by hand. You can, do that. You can calculate the mean. I wouldn't do that by hand, but you can do it by hand, right? I would use the mean function in Excel, right? Equals mean and so forth. Compute one pooled standard deviation. You're going to have to figure out how to compute a standard deviation in Excel. It's the same sort of thing, but you do it for blocks 3 and 6 and 4 and 7. So this would be like practice, real. So 3 and 6 are the practice blocks and 4 and 7 are the real blocks. So you just calculate the standard deviation for all of them together. And then you replace error latency with the block mean. So everything you deleted here, every time they missed one, here you just replace it with the mean. That's all you do. And then you got no log transformations. And then you average the resulting values for each of the 4 blocks. So, right, like practice real congruent, practice real incongruent. Divide each difference. So then you calculate 2 differences. B6 minus B3, right? That's practice. Let's say B6 in this case is incongruent, should be longer, minus B3, right? So always have your incongruent block first, minus your incongruent block. Same thing goes for B7 minus B4. Notice that right there. Divide each difference by the associated pool trial standard deviation from step 6, which we mentioned here, and average the 2 quotients. They're D-scores, or Cohen's D's. This is telling you how many standard deviations apart the 2 response trials are versus incongruent and congruent. So with that stated, that's one way to do it. Another way to do it is to go ahead and, go ahead and go here. Like, you can do an IAT calculation with R. If you're good with computers and want to mess around, you can try to play around with this and it'll do it all for you. But ultimately, at the end of the day, if you do things like with Excel, I'm not. Oh, here you. Oh, really, Excel? Really, you're gonna treat me like that? Right. So I'm looking at here. We got block 3, block 4, block 6. I didn't label this one, but that's block 7. Sorry, I didn't label that, but you now see that. I'll change it, right? And so here you got like incongruent, congruent, right? Block 6, block 7. These are all incongruents. I have them together, right? So essentially, first step, we look for people with scores higher than 10,000. There's none in here. There are none in here at all. So there it is, right? Then it says remove any participants who have more than 10% of their trials, less than, I think it was 300 milliseconds. We don't see that here. You're not really, you got a few here that are close, but not really. This person is above that range. So we're good here, right? And then it's like, well, sometimes you have to calculate a standard deviation. Right? So that is the standard deviation right there, right? And let me just see here which formula I'm using. STDEV Excel. Right? So there we go. No big deal. So, your mean equals your mean. Oh, no, that's right. Equals the average of all of these guys together, right? Boom, right? That's how you do that. So essentially, I'm not going to show you exactly how to calculate it on here, but I'm giving you those. Those are the two things you need, right? Standard deviation. You got to hit equals standard dev, right? And you put in your numbers. You want the standard deviation of. Hit enter, and that's your standard deviation, right? You want your mean. You got to go average equals average of all of these. It's really not that bad. I just walked you through the steps, but not on the file itself. But essentially, you're like, oh, is it greater than 10,000? Is it less than 300? How many are them less than 300? You don't have to worry about that. But look at these. When it's 0, they missed it, right? So they did not get it correct. So these ones are going to eventually be deleted, right, and replaced with the means. And then you want to take the incongruent minus the congruent, divided by the standard deviation. So this is like the practice blocks and the real blocks. So this really isn't that hard. And now you know how to do it, hopefully. So I'm sorry for another crappy installment of Dr. D's crappy videos, but here you go. And this is how you complete this assignment. It should take you 15 minutes, maybe less. Yeah, so it's not really that big of a deal.